Hello, in this video we'll learn how to calculate standard deviation, standard error, and then use that to calculate confidence intervals. So let's start by looking at the question. We have some data from a group of university students. Use this data to estimate the mean weight of the group with 95% confidence interval. So we have weights from 10 members of the group, and we're going to start by totaling these weights. Now I'm going to be using Excel, but you can do all of these calculations by hand. So the first step is to total all the weights. So Excel is pretty straightforward, and the total we get is 678. Okay. Next we calculate the mean. Remember, the mean is simply the total divided by the number of elements, that data points that you have. So in this case we have 10 data points, so it would be this total divided by 10, and that gives us 67.8. Now you want to actually draw a table if you're doing this by hand, and the table would have first, so you have the serial number of the data, the actual value, and then you have a column where you calculate the difference between the mean and each individual value. So in this case the individual value is 81, and I want to get the difference, so I subtract the mean from this. So that's 13.2. Now you would repeat the same calculation for all the data values. Okay, so we now have the difference between each data point and the mean value or the sample. Next, we want to get the square of the difference. So we take the same value here and we square it. Okay, so there's a square, and again repeat this calculation for all 10 numbers. Okay, so next you add up all these square of the means and mean difference, and that gives us so 651.6. Now this is called a variance. So variance is simply represents, if you look on this side where the formula is, variance represents this term. So we've taken the sum of the square of the difference from the mean for each point, and that total is called a variance. Now we have to convert this into standard deviation. To get to standard deviation, there are two possibilities. If we had data from all the group, which we call the population, then we would use something which would be a slight difference from this formula, because we don't have a -1. But whenever you have a sample, you would use a -1. So in this case we have a sample. So all we have to do is take this number divided by n-1, which is 10 minus 1 is 9, and take a square root of that. Let's go ahead and do that. So this divided by n is 10, so -1, and we take a square root of this. Okay, so 8.51 is the standard deviation. Next step, we want to calculate the, so we've done the standard deviation, and that's represented by S over here. The next step is to calculate the standard error of the mean. To do that, all you have to do is take this number which you got with standard deviation divided by square root of n. N is the number of data points. So let's go ahead and do that. So it's this standard deviation divided by 10 is the number of data points, and we take a square root of that. So 2.69 is the standard error of the mean. Okay, now if you look at this side, so in this formula we're looking for confidence interval. To get the confidence interval, notice we have the mean, which is represented by x bar. We know this value. We know SE, which is the standard error. That's done. Now we need a value which is called Z. Z is going to come from the table over here, In this case, we've said that we want a 95% confidence interval. So you look for 95. So this is 95, and the z value associated with that is 1.96. So you put 1.96 over here, and now simply we just need to do this calculation. So the upper range would be the mean value plus z into standard error, and the lower range would be the mean value minus z value into the standard error. So we have the upper and lower range for the confidence interval. Now let's understand what this confidence interval means. So the confidence interval means that based on this sample, we can say that if we took the whole group and we found the average weight of this group, the average weight will lie somewhere between these numbers. So it will lie between 73 kilograms and 62.5 kilograms. So that we are 95% sure that if we got the actual value, it will lie somewhere in between these. What if we want to get a higher confidence interval? So we could say, how about a 99% confidence interval? Notice that as I increase the confidence interval, the z value increases. As the z value increases, the range of means, upper and lower range, will also increase. That makes sense, right? If you want to be 99% sure, then the range has to be bigger as compared to being 95% sure. Let's try that out. So for 99%, I would use a value of 2.58, and notice now the range has increased. So now I'm saying if I get the value for the whole group, there is a 99% likelihood that the mean will be between 74.7 kilos and 60.86 kilos. Okay, so that's how we use these formulas. So remember, when you're starting, you start by calculating the mean over here, and then you calculate the difference between the mean and the data points. Then you square those differences, add them up. That gives you the variance. Use this formula over here to convert the variance into standard deviation. Then use this formula over here to get the standard error. Then use this table to get the z value that you're looking for. So if you've been told that it's 95% confidence interval, then it's 1.96. If you've been told it's 99.7, then it'll be 3. So use the z value and then use this formula over here to calculate the lower endpoint and the upper endpoint of your range. Okay, I hope that makes it clear. Thank you.